Hello, this is the solution video for the glitching screen problem from BGOpen 2021. So, in the glitching screen problem, your task is to help Peter determine what the next train stop is. So the first part of the input is how the screen normally looks for each of the stops on the train. So in the sample case 1, the two first screens are the 6 first lines. So each of the first screens in the input describe what pixels are normally on for that specific stop. So X means that the pixel is on and the dot means that the pixel is off. And the last screen is what the screen is currently displaying. And here is the same, the X means that the pixels are on and dot means that the pixels are off. But the thing about the last screen is that it is partly broken, so some of the pixels do not work. This means that some pixels that would normally be on are off. So your task is to determine, is it still possible to see which stop it is? So let's start by looking at some simple cases. So here we have two stops normally, and we have the broken screen at the bottom. So we can see that because the middle pixel is on the broken screen, it cannot be stop 1, but it has to be stop 0 because this is the only stop that has a pixel on in the middle. So this is a guess instance. Now let's look at a simple no instance. So here we can see that these are the two stops and how they normally look, and this is the broken screen. So the problem here is that we don't know what pixels are broken. So if this was the pixel that was broken, this could potentially be the first stop, but it could also be the second stop if it's not broken. So here we get unknown. So the idea for the algorithm here is that we compare each of the screens, how they normally look, to the broken screen. So if a pixel is on the broken screen and would normally be on for some stop, we know that it is not that stop. So let's start writing the algorithm. So we start by reading the input. I will skip that part of the code. So we start by defining a function that checks if a stop matches the broken screen. So we go over all the pixels, and if a pixel is off in how the screen normally looks, and it is off if it's on in the broken screen, we know that these two screens do not match, and we return false. And if this is not the case for any of the pixels, the broken screen could potentially show the stop that we are checking. To finish our algorithm, we go over all the stops and we check each of the stops. So if a stop matches the broken screen, we increase our counter by 1, and we print yes if it can only be one of the stops, because then we can help Peter determine what the next stop is. And if it's not one, we print no, because we are not able to determine what the next stop is.